Okay, so I've just been asked to go over the Hungarian method today, and it's just a method used for solving more complicated problems, more complicated assignment problems. So in this example here, we have Alan, Bindi, and Chris, and they've all made a quote for different jobs, job 1, 2, and 3, like that. And all the quotes are organised in this table here. So we have Alan, Bindi, and Chris, and their quote for job 1 is 130, 120, and 160. And what the task is to assign one job to each person for as little cost as possible. And one of the ways we can do this is by using the Hungarian method or the Hungarian algorithm. So we have the test. So we have to cross out all the zeros in the matrix with as few horizontal and vertical lines as possible. So if n lines must be used, and the order of the matrix is n by n. So if you go back to the previous slide, that was a 3 by 3 matrix. Then we need to use 3 lines to cross out all the zeros. Okay, but if it's possible to cross them out with 2, then we have to continue on with the next step in this algorithm. So the first step is row reduction, which I'll talk about first of all, and then column reduction. Then if we still need step 3, it's called the Hungarian method, and we'll go over that when we need to. And then finally the assignment there as well. Okay, so there are no zeros in the first step, so we start with row reduction. So what you do is you look at each row, and remember rows go along that way and columns go down. So I might just write that in, rows and columns. Okay, so then we look at the first row, and 130 was the smallest in that row, so we subtract 130 from each of the other numbers in that row, and you get 0, and 160 minus 30 is 30, and 480 minus 130 is 350. Okay, and you do the same thing, so in the second row you're going to subtract 120 from each line, and you get 0 there, 60 there, and 400. In the final one, subtract 140 from each, so you get 0, 20, and 360. Then you have to apply the test, so crossing out the zeros with as little lines as possible, we can do that, like that. So obviously those ones. You might want to say, well, we can actually cross them out with 3, and like that way, and then our test is done, but obviously 2 is the minimum. So then you need to move on to column reduction, which is exactly the same as row reduction, except that you just go down the columns instead. So in the first column up here, sorry, it's going to be messy now, but 0 was the first. 0 is the smallest number in the first column, so if you subtract 0 from everything, everything stays the same. Same with the second column here, if you subtract 0 from everything, then everything stays the same. But in this column here, 350 was the smallest number, so you end up getting 350 minus 350 is 0, 400 minus 350 is 50, and then 360 minus 350 is 10. So that's how we get to column reduction. Then you apply the test again, and because now you have to use 3 lines to cross them out, then you can just apply the assignment like this. Okay, assignment like that, and you find that the cheapest way is to give Alan job 3, Bindi job 1, and Chris job 2, and the expected cost here is $720, or the minimum cost. Alright. So I want to, in the next video, I'll look at the next, maybe we can just continue in this video. I'll make another video, and in this one we will have to use the Hungarian method.